Welcome to Physics Blender e-learning platform. I am teacher Huda Al-Iraqi and we are discussing some challenging questions about motion. To be more specific, linear motion. We are discussing questions related to paper 1 for core and extended candidates classwork. We have 32 questions. You can find all documents if you join Physics Blender Telegram channel. If we have the distance traveled in equal periods of time getting greater, it means the speed is increasing. If the distance traveled in equal periods of time are getting smaller, it means the speed or the car is slowing down. So when we compare, if you compare A, we have here 100 meters and then 100 meters during the next second. Here the distance is 90 and then it becomes also 90, which means constant speed. The question is asking you about increasing speed. Here during the first second, the distance traveled is 80 and then it becomes here 110. Okay, here during the first second we have 100 meters. During the second we have only 80 meters, which means the distance traveled is getting smaller. So here slowing down, here speeding up. The correct answer is C. Okay, if you multiply speed times time, so 20 times 400, your answer will be 8,000 meters. This answer, which is mentioned, one of the choices, this will be wrong answer. You have to use the area under the graph. You can only use this and it will be okay if you have constant speed. Because if you use area under the graph, it will be speed times time, representing length times width, which is also the same numerical value. You got my point? So please, here you have to calculate the area under the graph. Okay, the area under the graph for this triangle, it will be half times base times height. Base here representing time, height here representing speed, and this half as if we are calculating the average speed, because the speed here is not constant, the speed is changing. Okay, so again, this answer, if you use the magic triangle, you will get wrong answer, incorrect answer, and it will be one of the choices. So please don't do this. Back to the rule, the equation, the area under the graph is equal to the distance traveled. So half times time, which is 400, times the speed, 20. The final answer is 4,000 meters. Calculate average speed. Here will be equal to the sum of initial and final velocity divided by 2. Why we didn't use this equation in question 1? Go back to part 1 and question 1. Because simply the velocity given in the question, it was not the initial and final velocity. Okay, so we can use this one. It will be, if you can read here, the initial velocity is 5 meters per second and the final one here is 17. So initial velocity, so it will be 5 plus 17 divided by 2. Your answer will be 22 divided by 2 equals 11 meters per second. You can use average speed is equal to total distance traveled divided by total time taken. Total distance traveled divided by total time taken. Total distance traveled is equal to the area under the graph. How can we calculate the area under the graph? If you look at the shaded area under the graph, looks like trapezium. How can you calculate the area of trapezium? Area of trapezium is equal to base 1 plus base 2 divided by 2 all times height. And the time taken here, you know it's 6. Check you have consistent units. If you calculate the area of trapezium, the side, the base one here is 5. The second one is 17. So 5 plus 17 divided by 2 all times height, which is 6. This is the height, 6. So the height here 6 divided by 6. So your final answer will be 22 divided by 2 times 6 all divided by 6. So your final answer also will be 11 meters per second. Okay guys, so you have method number 1, first method, and you have method 2. Is it clear? Let me know in the comments if you have any questions. So we have distance time graph, we have speed time graph, okay, but we want to choose the correct pair of graphs. The car travels at constant speed. First of all, we will exclude A, because here distance time graph, we have a horizontal line parallel to x-axis. It means stationary object. Okay. Also here we have a stationary object. The object is not moving at all. Okay, so you have to choose between C and D. Okay, let's look at distance time graph. We have a straight line passing through the origin. It means constant speed. What about the second graph, speed time graph? Horizontal line parallel to the x-axis on the speed time graph. So it means constant speed. So this one is the correct answer. Let's discuss D also. Here the graph is representing constant speed, but here we have constant acceleration. So we have to choose the correct pair of graphs showing constant speed. This question is very important. Question 13, the diagram showing speed time graph for a car. Which row describes the motion of the car at point X and at point Y? At point X here, we have a straight line passing through the origin. Okay, you can say the car is moving at constant speed. No, you have to look at the y-axis first. If you have a speed time graph, you know that the gradient in this case is equal to acceleration. So if the gradient is equal to 0, it means 0 acceleration, and this is the case of y. We have a horizontal line parallel to the x-axis, it means 0 gradient. So in this case, 0 acceleration means constant speed. The speed is not changing. What about section X, or at a point X? At a point X, the speed is increasing, which means the speed is changing. Okay, so we have to choose y, constant speed, and we have here speed is changing. The correct answer will be D. Average speed is equal to 60 kilometers per hour. Total distance is unknown. Time taken is 15, but 15 minutes. 2 hours, because you have the final answer, the choices are given in kilometers. So the distance and the average speed here is 60 kilometers per hour. So you have to convert minutes to hours. You have to divide by 60. So 15 divided by 60 is 0.25 hours. So here I will substitute 0.25 hours, cross multiplication. So your final answer, total distance traveled, will be equal to 60 times 0.25. The final answer is 15. Your correct answer is B.
Subscribe for more videos. I love Physics Blender. I love Physics Blender. I love Physics Blender. I love Physics